Hey everyone, in this video we're going to take a look at how to use the midpoint approximation method to estimate the area underneath a curve. As with the other approximation methods like the left endpoint approximation and the right endpoint approximation, the midpoint approximation method makes use of the combined areas of rectangles to approximate the area under a curve. So let's get started. In example 10.5.1 we are to approximate the area underneath the curve f at x equals x squared, which is this green one right here. And what we're going to do is estimate it by figuring out the areas of these rectangles. Now, here's where you can see that why it's called the midpoint approximation. It's because the heights of these rectangles are determined by the function at the midpoint of the base, right? So we've got the midpoint of the base right here, the midpoint of the base of this rectangle is right here, and right here for the fourth rectangle. Okay, so to figure out the heights of those rectangles, we're going to have to figure out the value of the function at these points, or the midpoints of the base. Now, as you'll recall, the area of a rectangle is area equals length times width. So the width of these rectangles is constant, right? The width of each of these four rectangles is the difference between 0.25 and 0.5, which is 0.25. And then the only difference is the length of the rectangles would be the heights of the rectangles, and so they're different. And again, they will be evaluated based on the value of the function at the midpoint. Okay, so then that means the area of, or the area that we would approximate by figuring out the areas of the rectangles under the curve would be, well, we would start with 0.25. Okay, so I'm going to start with the width. That's common to all four rectangles. And then the height of this first rectangle would be the value of the function at whatever the midpoint is between 0 and 0.25. Okay, so that would be 0 plus 0.25, which is 0.25 divided by 2, plus the height of the second rectangle would be the average between 0.25 and 0.5. And now the height of the third rectangle, its height is the average of 0.5 and 0.75. And finally, the fourth rectangle, its height will be the average of 0.75 and 1. Okay. All right, so that's all we have to figure out. Now it's just a bit of number crunching. Okay, so I'm going to simplify here a little bit. So 0.25 would be 0.25. Excuse me, and in retrospect, I think I might actually go with fractions here, although you could stick with decimals. You'll have to have your calculator handy. So there's a quarter, and 0.25, which is a quarter divided by 2, would be an eighth. And a quarter plus a half would be 3/4, divided by 2 would be 3/8, or 0.375 if you're using a calculator. Half and 3/4 would be 5/4, divided by 2 is 5/8. And 3/4 plus 1 would be 7/4, divided by 2 is 7/8. Okay, so you can kind of see this this pattern with odd numbers in the numerator: 1/8, 3/8, 5/8, 7/8. Now you got to keep in mind that the function is in fact x squared, and so f at 1/8 would be 1/8 squared, f at 3/8 would be 3/8 squared, etc. So basically we have this. We've got 1 over 64, or maybe I should write it this way so that you can see every step here. Okay, so 1/4, this would be 1/8 squared plus 3/8 squared plus 5/8 squared plus 7/8 squared. Okay, and it's squared because that's precisely what the value of the function is at each of these points, at each of these midpoints. It's because it's y equals x squared, we're subbing in the x value at the midpoint of the base. That gives us the corresponding height of each rectangle. So we end up with 1/4, and the denominator squared would all be 64. So this would just be 1 squared plus 3 squared plus 5 squared plus 7 squared all over 8 squared. Okay, and so just a couple more steps here. That's 1/4. That's 1 plus 9 is 10. 10 plus 25 is 35. 35 plus 49. 35 plus 50 is 85. So 84. Okay, and that's all over 64. And so if you take out your calculator, I think at the end of the day, well, should we continue with fractions? 4 goes into itself once. 4 goes into 84 21 times. We end up with 21 over 64, or approximately equal to 0.328. Okay, and there you have it, the midpoint approximation of the area under the curve y equals x squared from 0 to 1 using the midpoint approximation on 4 rectangles.